A uniform chain of 6 meter length is placed on a table such that a part of its length is hanging over the edge of the table. The system is at rest. So the system is at rest. The coefficient of static friction between the chain and the surface of the table is 0.5. The maximum length of the chain hanging from the table is. So what is the maximum length of the chain hanging on this table? This was asked in JEE main. See here. Now what is preventing this chain from sliding? Okay. See, frictional force is preventing it. So frictional force, it is acting in this direction. Okay, frictional force is acting in this direction, that is preventing this chain to fall down, So frictional force, maximum value of frictional force depends upon normal. Okay, mu n gives the frictional force, and more the value of normal, more will be the frictional force. Mu is constant, that is 0.5 here. So normal reaction, if you see, if this chain part is more on this vertical side, means more it is hanging, means here weight will be decreased. Whatever this is placed on the table, this portion weight will be decreased, because more will be hanging, means less portion, less length will be here. Consequently, there will be less mass, and less mass means less weight. Less weight will be acting downward. Less weight will be acting downward. Less weight will be acting downward. If I write this portion is m1, then m1g will be in this direction, and here m2g, this portion, okay, this portion is m2g. I have divided into two part, this chain into two part. Okay, so m2g here, it is balanced by normal. See here, so normal is depending upon weight, and weight is depending upon how much chain is hanging, how long chain is hanging, is placed on this table. If more is hanging, if more part of the chain is hanging, means this part will be less, and less means this weight will be less. If weight is less, means consequently normal reaction will be less, and if normal reaction is less, frictional force will be less, and which won't be sufficient enough to keep it hanging. It may fall down. So here frictional force is preventing this chain to fall down, and frictional force is depending upon this normal reaction. And if more of this chain part is hanging, means more and more we are keeping this side, means this frictional force won't be sufficient, and it will roll over. Okay, it will fall down. So again, one more thing I want to tell, this side there won't be any friction, because these two surfaces are not pressing each other. Whenever two surfaces do not press upon each other, means there won't be any normal reaction. Okay, because normal reaction is due to interaction of electron, or you can say interaction of atomic particle on these two surfaces should press. So whenever two surfaces press, then normal reaction occurs, otherwise not. So these two surfaces are not pressing, there is no normal reaction, there is no frictional force this side. You may feel friction here, think friction will be there, but here friction is almost nil, so we'll take it 0, this side friction. So only friction is this side. Now let us find this m1. M1, so for that I will divide. Say total length is 6 meter, so I will write this as L, then this portion length will be 6 minus L. So m1 will be mass per unit length. If total mass is m, okay, mass of the chain, capital M is the mass of chain, Now m1 will be total mass divided by total length, that is mass per unit length into L. So that is m1. Similarly m2 will be mass per unit length into available length, that is 6 minus L. Here L is the maximum length, okay, that can be hanged. Now m1g here, it is balanced by tension. Okay, it is balanced by tension, it is balanced by tension. So you can write T is equal to how much? T is equal to m1g, that is equal to m by 6 Lg. So here, now for this portion, tension will be acting in this direction. So this T and this friction, so they should cancel each other, or you can say this tension T is pulling it downward, this friction should cancel this value of tension, which is the force that is pulling this part downward. So this tension is pulling it this side, right side, this friction is opposing it. So this maximum value of frictional force should be able to cancel this tension. then only this chain remains hang, okay, on this table. Otherwise it will roll over, it will fall down. So maximum value of friction should be able to cancel this tension. So maximum value of friction, F max you can find F max that is equal to mu n. So mu n gives maximum value of friction. Mu is 0.5. Normal is how much? Normal is, see, m2g. So normal is m2g. You can clearly see m2g and this normal, they are cancelling each other, since this is stable, okay, it is not moving in vertical direction. So m2g is cancelled by normal. So n is equal to m2g. N is equal to m2g. You can see here n is equal to m2g. So you will write m2 is here, clearly you can see here m2 is how much? M2, that is m by 6 into 6 minus L g. So maximum value of friction is this. So situation is, now let us equate. F max, clearly you can see F max is equal to T. So what you will write? F max, condition is F max is equal to T. This implies maximum value of friction 0.5 m divided by 6 minus L g, that is equal to tension. T is equal to m by 6 Lg. So you see here m6 g will also get cancelled. So what you will get? If you see here, what you will get, I'll write it here, this portion I'll write. So you will get 0.56, that means 3. So 3 minus 0.5 L, that is equal to L. This implies 1.5 L is equal to 3, that is L is equal to 2 meter. So this should be your answer. So this is your answer, okay. So maximum length, that is hanging here, is equal to 2 meter. This is your correct answer.
Don't forget to like, comment and subscribe PK Dye Physics for more videos.